Okay, 7.5. So 7.5 is just going to talk about some relationships that we see if we split triangles. All right, so first theorem says if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So let's say I have triangle dog, and if I draw this line and I intersect these two sides, but I make that line parallel, I'm going to call this hot dog. Then what I'm saying is DH over OH is going to be equal to GT over OT. So this over this will be equal to this over this, okay? All right, so we're going to prove that below. So what I want you to do now is kind of think about this is my given, and this is what I'm trying to prove. And statements, reasons, I'm not writing it all out. All right, let's say I'm given triangle dog with HT parallel to DG. So that's your given. Okay, so if they're parallel, then I know that, so obviously if the sides are proportional, it would help if I could show the triangles are similar. So if these sides are parallel, then I know that these two angles right here, so angle OHT is congruent to angle ODG, and I also could say that these angles, so these angles right here, and then these angles, angle OTH is congruent to angle OGD, because parallel lines tell me that the corresponding angles are congruent. So now I know the two triangles are similar. So triangle hot is similar to triangle dog because of angle-angle similarity. But if I know triangles are similar, then I know that like DO over OH is proportional to GO over OT. So I know that the sides are proportional. So this is just a definition of similar triangles. But I also know that DO is just DH plus OH. And I know that GO is just GT plus OT. And my reason here is I can just say this is from the segment addition postulate. I know that if I add pieces of a segment, they're going to give me the whole segment. So I could write this like this. So DH plus OH over OH is equal to GO is equal to GT plus OT over OT. I just did substitution. I need more room. But then, if you remember, we had one of those properties of proportions. So now I can just say that DH over OH is equal to GT over OT. This is properties. This is from section 1 of proportions. This was actually number 3. Again, I'm not going to make you memorize those numbers there. But this was the property that said, like, if you had A plus B over B, it's equal to like C plus D over D. So then like A over B is like, it was just an equivalent expression, if you remember. All right, and that was what I was trying to prove. So instead of me worrying about the two big triangles that are similar, like in this problem, I can just use this side splitter theorem and say that A plus 4 over A is equal to 18 over 12. And I can cross multiply, so I get 12A plus 48 is equal to 18A. Subtract 12 from both sides, so then I have 48 is equal to 6A. Divide both sides by 6, A is equal to 8. Okay? So it just makes it a little bit easier. Now, just so you know, you could go like A over 12 is equal to A plus 4 over 18, because again, if I cross multiply, I'm still multiplying the same things. You could go like A over, I could write it this way, A over A plus 4 is equal to 12 over 18, because again, if I cross multiply, I'm multiplying the same things. So there's other ways you can write those, as long as in the end you're multiplying it the same way that we just multiplied it here. All right, this corollary says that if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. So if I had three parallel lines, so these are all my three lines, they're all parallel to each other. And then I have two transversals that they're intersecting. What it's saying here is that these little pieces right here are going to be proportional. So in this example right here, it says finding the length of site C along the road. So here's site C. These segments are all parallel. I've got the two transversals, so I could do 7.2 over 8 is equal to, I don't know, C over 6.4. Cross multiply, 8C is equal to 46.08. Divide both sides by 8. 5.76 yards. Okay? All right, theorem 7.5, triangle angle bisector theorem. So if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So I'm bisecting this angle. So what this is saying is that then x over y is equal to w over z. So if that is bisecting that angle, then I divide it proportionally. So here, and again, you can kind of like, you got to realize, so I'll set it up like I did up here. Cross multiply. But you need to realize that like you could set this up, like I could have done y over 9.6 is equal to 24 over 16, because if I cross multiply, I'm still going to get the same outcomes that I had here. You could do y over 24 is equal to 9.6 over 16. Again, I cross multiply, I'm still going to get the same outcome I would have gotten here. I can't do though y over 16 is equal to like 9.6 over 24. Like that's not, like I can't say this over this is equal to this over this. Like that's not lining everything up right. So this is a big no. Don't do that. Okay, but there's other ways you could start off these problems. All right, so again, got a couple homework problems I'll do with you here. So 33. Okay. So 33, you can kind of see that we've got those parallel line things going on there. So I know I've got proportions there. So I can say like this one over this one is equal to this one over this one. Okay? So then what I would do is I will cross multiply. So now when I cross multiply this one, you've got to be careful here that you're like distributing everything. I'm actually going to write out the extra step so you can see it. So this would be 24x squared. This would be minus 40x. Over here I'd have 20x squared plus 40x. Okay, so then I'm going to put everything on one side because I've got that x squared. So I'll subtract the 20x squared, so I have 4x squared. I'm going to subtract the 40x squared, so I get 80x. This will be equal to 0 now. I can factor out a 4 and I can factor out an x. So 4x, so I'd be left with an x here, and I'd be left with 20, but I don't have any more x's because I factored it out. So one of these two has to be 0. So it could either be 4x is equal to 0 or x minus 20 is equal to 0. 4x would be equal to 0 would just tell me that x was 0, which doesn't make a whole lot of sense in the geometry picture, so this one's just going to be gone. Here, add 20, so x is 20. X being 20 does make sense. This could just be 80 and this is 100 and then so forth over there, okay? So that's 33. 41. Okay. So 41 says an angle bisector divides the opposite triangles into segments that are 5 and 3 centimeters long. And the second side of the triangle is 7.5. Find all possible lengths for the third side of the triangle. So okay. So for 41, I know that the angle bisector splits the triangle, splits that opposite side into segments that are 3 and 5. And I know that one of the other sides is 7.5. But I don't know where that 7.5 is. Is it adjacent to the 3 or is it adjacent to the 5? So maybe it looks like that. So I'm actually going to set it up both ways and solve both of these triangles. So here I can do 7.5 over 3 is equal to x over 5. Cross multiply, so 3x is equal to 37.5. Divide by 3, x is 12.5. And then over here, I could do x over 3 is equal to 7.5 over 5, cross multiply, and x is equal to 4.5. Okay, so those are the two answers for that one. All right, last one that I have here is 44. So 44 says we're going to solve for x. Okay, so with 44 here, let's see here. Sorry, I'm pausing because I'm trying to remember how I did it. Oh, okay. So I'm going to flip the triangle a little bit here so you can see something. let's see here, let's call this S. So that's S, here's R, here's Q, and then here's P, and here's T. And then this line right here is parallel to this line, and QR is 2, RS is 3, QP is X, and PT is 3. All right, if you look right here, this is that first theorem that we talked about with the side splitter theorem. So let's just call this y here. So 3 over 2 is equal to y over 3, 9, 2y, so y is equal to 4.5. So now I know that this piece is 4.5. So now what I'm going to do is I'm going to go back here. So this piece right here is 4.5. So now I can use that angle bisector idea. So I've got x over 3 is equal to 5 over 4.5, because this is 5 here, 3 and 2. Cross multiply 4.5x is equal to 15. X ends up being equal to 3. It's like 3 1/3. Okay? Alrighty. That takes care of that section.